Hello students, this is Professor Chalai, and in this video we're just going to look at solution stoichiometry, and as always you can follow along with our chapter 4 workbook. Now at this point you should be able to do both number 34 and 35 because we've done similar practice before, but these are just stoichiometry calculations where we're dealing with solutions instead of solids like we've done before, but they're going to be no different than stoichiometry calculations with solid samples, or no different than stoichiometry calculations with acid-base reactions, for example. So I'd like you to pause the video here, try numbers 34 and 35 by yourself, and then when you unpause, I'll go over them together with you. Okay, so let's look at number 34. We have this reaction between potassium chloride and lead nitrate, and it says it's asking for the volume in liters of the concentration of potassium chloride. They give us 0.150, and it completely reacts with 1.150 liters of a solution that is 0.175 molars of lead nitrate. So our known solution here is lead nitrate because we know the volume and the concentration, and our unknown solution will be the potassium chloride because we only know the concentration but not the volume. So let's do what we do, which is first convert the number of moles of lead nitrate, which can tell us the number of moles of potassium chloride, which then will be able to let us find the volume of potassium chloride. So let's do that. So we start with 0.150 liters, so 0.150 liters of lead nitrate. We can convert to number of moles of lead nitrate using the concentration, and we don't need to convert to liters because it's already in liters, so that's very nice. So 1.175 moles of lead nitrate per liter of lead nitrate. So that cancels out. Now that we have moles of lead nitrate, we can use our mole ratio. So we know that for 1 mole of lead nitrate, we react with 2 moles of KCl. So let's do that. 1 mole of lead 2 nitrate reacts with 2 moles of potassium chloride. So that cancels out. And now that we have moles of potassium chloride, we can find the volume of potassium chloride by using its concentration. The concentration is moles over liters, so you want moles on the bottom to cancel out. It's 0.150 moles of KCl per liters of KCl. So we plug all of this into our calculator and we should get a value of 0.350 liters of KCl to 3 significant figures. And that's it. Let's try number 35. If you haven't yet worked it out, please do so now. Pause the video, and when you unpause, we'll do it together. Okay, in this question, we're asked for the volume in milliliters of nitric acid, and they give us the concentration. It's 0.150 molars. I think we're missing a big M there. So that's our unknown, and it'll completely react with 35.7 milliliters of 0.108 molar solution of Na2CO3, so sodium carbonate. So that's our known solution. We already have a balanced chemical equation, so our life is made simple. We can easily find the mole ratios. So sodium carbonate is our known solution. Nitric acid is our unknown, so let's start with sodium carbonate. 35.7 mils of sodium carbonate. We need to first convert to liters before we can use concentration, so 1000 milliliter per 1 liter. And the concentration is 0.108 moles of sodium carbonate per liters of sodium carbonate. So liters cancel out there. So now we have moles of sodium carbonate. Let's use our mole ratios. So in this problem, 1 mole of sodium carbonate reacts with 2 moles of nitric acid, so 1 mole sodium carbonate reacts with 2 moles of nitric acid. So that cancels out. So now we're left with moles of nitric acid. We can convert from moles of nitric acid to volume of nitric acid using the concentration. And so to do that, we divide by the concentration, right? So it's 0.150 moles of nitric acid per liters of nitric acid. That's HNO3. However, they want the volume in milliliters, right? So we need to convert liters to milliliters. So finally, that's just 1 liter is 1,000 milliliters. So our answer should be in milliliters of nitric acid. So milliliters of nitric acid. So now all we have to do is punch these numbers into our calculator. And if you do so, you will get 51.4, right? 3 significant figures here, and here, and here. So 3 significant figures in our answer. And there we have it. There are a lot more questions like these for practice in our skills practice sessions. So please, if you don't feel comfortable with them, try them out and send me a message if you think you couldn't quite figure it out. But that will bring us to the end of chapter 4. Next week, we'll start with chapter 5. I'll see you then. Bye.